For our final story tonight, let's delve into the topic of parenting. They say that raising a child requires a collective effort, often described as, "it takes a village." However, thanks to advancements in medical science, the process of creating a child can now involve the DNA of 3 parents. Yes, you heard that right, 3 individuals' DNA coming together to conceive one baby. This procedure, known as 3-parent babies, has the potential to be life-saving. It's not a recent development though, as the first 3-parent baby was born back in 2016. Since then, numerous such babies have been brought into the world. This remarkable progress in science highlights how far we have come. However, it's crucial to acknowledge that this procedure is not without risks. You may recall learning about mitochondria as the powerhouse of the cell during your school days. Although this knowledge might not have been the most captivating, it is particularly relevant to this story. We'll explore the concept of 3-parent babies, where mitochondria facts will come in handy. In essence, babies, like all living organisms, are made up of DNA inherited from their parents. With 3-parent babies, the process is similar, except that instead of only 2 parents contributing their DNA, the father providing sperm and the mother providing the egg, a female donor also contributes her DNA. Through in vitro fertilization, IVF, the embryo is formed outside the womb in a laboratory dish and is later implanted into the mother's womb. This process is known as mitochondrial donation treatment. Now, you might be wondering why an additional woman's DNA is required if the mother already provides an egg, and why only a woman can be the donor. This is where mitochondria play a crucial role. What exactly are mitochondria? They are like tiny compartments found in nearly every cell of our bodies. Their main function is converting food into usable energy, but unfortunately, some mitochondria malfunction. Defective mitochondria pose serious health risks, as they not only fail to produce energy but can also lead to brain damage, heart failure, blindness, and muscle wasting. These mitochondrial diseases are incurable and genetic, meaning they can be passed on to children. Alarmingly, approximately 1 in 6,000 babies are born with mitochondrial diseases each year, and the conditions are often fatal, with many infants dying within hours of birth. Families have tragically lost multiple children to these diseases. Naturally, parents want to shield their babies from such conditions, and the mitochondrial donation treatment offers them the only solution. Since people inherit all their mitochondria from a woman, the genes of a third female donor are needed, even if only 0.1% of the baby's genes come from her. This addition ensures that the baby receives healthy mitochondria from the donor, rather than the faulty ones inherited from the parents. This intervention leads to the birth of a healthy baby, which has now occurred for the first time in the UK. However, this isn't the world's first case of a 3-parent baby. Mexico witnessed such a birth in 2016, followed by Ukraine in 2017 and Greece in 2019. Clearly, the scientific community worldwide is making progress in this field, albeit at a cautious pace due to the associated risks. This technique is still relatively new, with health concerns surrounding it, resulting in its prohibition in countries like the United States and Canada. Additionally, ethical concerns arise due to the manipulation of natural biology. Furthermore, in a few cases, the process has proven unsuccessful. However, while these concerns are valid, we must also consider the consequences of not utilizing this technique. For thousands of families, this procedure represents their only hope. Striking a balance between caution and progress is the challenge we face.